My assumption is we're back. There's been a change in the schedule that I wanted to share with everybody. To take advantage of the great Andre's time before he has to run and leave, I thought it would be a great idea to do the panel that we have scheduled for the end of the day, to do that earlier. And so we're now going to have a panel at 2:15. That's going to be Andre, Herb, Iho, Dion, Nicholas, who you're about to meet, and of course, STL. And so you're going to want to ask them questions, basically related to what they talked about today, or anything, whatever. Just ask good questions again, like yesterday. So without further ado, as I said, the schedule has changed. I'd like to introduce Nicholas Gustafsson, who is an architect of what was once called Casablanca. It's now the C++ REST SDK. Nicholas.
Okay, thank you, Charles. So I'm going to talk about something that's kind of unusual. I think that most of you don't put Microsoft and open source software in the same sentence a lot, but Casablanca, or the C++ REST SDK, is exactly that. Let me just start by going to Codeplex, which is the or a Microsoft site for open source projects, and this is where Casablanca lives. We officially it's the C++ REST SDK, but we call it Casablanca. We have source code here. We have binary installs, and you can download it and just get it onto your machine quickly. We have the unit tests, et cetera, et cetera. So there's a whole bunch of stuff out there. And I just want to sort of anchor the rest of the presentation in this. What this is all about is trying to make it easier to build and consume cloud services with C++. There are already C APIs. Windows certainly has several HTTP stacks, several APIs of various generations to deal with communication across networks. The problem that we've seen with them, the problems fall into a couple of categories. One is they're synchronous, which is bad for responsive UIs. Or if they're not synchronous, they may be C-based, which is not giving the developer the full expressiveness and power of modern C++. Or they're not portable. They're not cross-platform. So we wanted to take the challenge of building a modern C++ API that was portable, fully used the power of asynchrony to build asynchronous, to build responsive and scalable UIs, or pieces of software, libraries, etc. Right? And we also think that C++ in general is valuable on the cloud. A lot of when we started this project, a lot of the pushback was, why would you do C++ in the cloud in the first place? Why would anybody care? And we think that while it may not be the silver bullet for all applications, C++ has a lot to offer these types of scenarios. One is, of course, the closeness to hardware, the compatibility across platforms, and just raw performance in sort of the core paradigms of the language. So Casablanca does two things. It addresses the client side, like your Windows or your Windows Phone, or your Linux. We currently are Windows and Linux based. It also addresses the server, allowing you to write, using our HTTP listener interface, a pure C++ based server. We think that a lot of the value proposition behind a library like Casablanca is about productivity. Performance is sort of table stakes. You have to be performant too, but it's about productivity. It's about writing asynchronous, responsive code but doing it with high programmer productivity. And we also think that, given that this type of library is not something that you really have any chance of charging for, we think that open source really fits the right model for release of this. We've been able to release now 3 versions since May of Casablanca. And we're getting a ton of feedback. And so the open source model really helps us be more agile and has really driven us to improving it quickly. So we're very happy with that model. Anyway, just to do a quick overview of what Casablanca, how it's built. There's operating system services underneath, of course, Windows, XP and forward, Windows Phone, Linux. And then we're relying on a couple of different low-level or lower-level stacks. WinHTTP is a C HTTP client stack for Windows 7, Windows 8 desktop, so also on XP and the server SKUs. PPL, which Dion touched on in his talk earlier, which is our programming model for composing asynchronous operations in general in C++ on Windows, but we're leveraging it fully in Casablanca. Boost is ASIO is what we're using on Linux for communication. And HTTP sys is the Windows server-side stack for HTTP. So that's the foundation. And then the next layer up is the actual Casablanca pieces, which is JSON for serialization, an HTTP client, and an HTTP listener. We have an experimental TCP, sort of a lower level stack also. We have async file streams because we feel that it is very commonly the case, and one of the demos is going to show that very directly, that you want to combine network I/O and file I/O, and you want to do it using the same composable mechanism. So we have a file I/O library that also builds on the same PPL tasks that we're using for networking. We're going to add WebSockets and potentially UDP in the future, but that's not currently there. And then you can imagine, and we have imagined, in fact, we prototyped several of these, libraries being built on top of this for things like Azure storage. Mobile services, as a library, we're shipping in the next version of Visual Studio, built on top of Casablanca. But you can imagine other APIs that are more product-specific being built on top of Casablanca, but they're not actually part of Casablanca. So asynchrony. Dion touched on asynchrony. It's important for responsive UIs. It's important for scalable I/O on servers, where you may be listening to more I/O contexts than you're actually serving. And so you're spending a lot of time waiting. And this is one where the productivity really comes into play, and where PPL has a role to improve the productivity of asynchronous programming. Dion demonstrated very clearly what happens when you try to do it with loops, to compose loops and tasks or asynchronous operations. PPL only gives you the foundation. It only gets you to where it's hard. In Dion's presentation, you need language support to go beyond that. But without something like tasks, it's much, much harder. Using, for example, the WinHTTP APIs, which are C-based on Windows, is very, very complicated if you were trying to do something general. So parallelism is hard, concurrence is harder. And the nasty thing is that users, at least of graphical applications, know when we didn't do it right. They see something like this. Or worse, you see just an application that refuses to paint, period, if you didn't set the icon correctly. And this is because we don't leverage this. Tony Hoare said that concurrent programs wait faster. That waiting is an essential aspect of how you write your concurrent programs. It's, in fact, sort of the pivot, if you will, around how concurrent programs need to be structured. OK. So what does this look in C++ today? We have futures, which are a way of representing outstanding computations, or the results of outstanding computations. One of the issues is that when you go to collect the results of futures, all that's currently available is the function get. You can call wait also, which blocks until it's available. But to actually retrieve the value, you call get. And get is a synchronous construct. In other words, it blocks the current thread until the value is available, or an exception can be propagated through it. And so when you're trying to compose something like I/O, you're going to be holding up a thread for a non-deterministic amount of time, because I/O is, generally speaking, fairly non-deterministic. And that can be very, well, it's bad, right? So, well, there's the problem that the .get is the problem, right? So we want to try to avoid that. Well, this is what PPL tasks do, right? And we are also proposing this, and I think DM touched on this. We're proposing similar features for as an extension or a sort of a new rev of Stud Future. So we want to take this functionality into the standard as well. But for Visual Studio right now, we have this special type that is a lot like Future, except we're calling it a task. And instead of Stud Async, we have a function called createTask that does essentially the same thing. Anyway, so we have a .get here too, because it's commonly the case that, well, I don't care about blocking the thread. I really just want to get the value, right? So it does block if that's what you ask for, right? But it's still a bad thing. It skipped something. No, okay. So if instead of calling .get, I hook on .then, and .then takes a lambda, then I can avoid blocking the current thread. In other words, the thread that calls createTask. But I can't collect the result on that thread, right? So this is the continuation passing or the continuation chaining approach to it, where you're saying what a continuation is in layman's terms is just the stuff that comes after, right, the operation. So if I express it with this in a callback fashion, then I get to do it on another thread, and that's kind of complicated, but it is at least avoiding the blocking the thread. A thread will be allocated to execute the continuation when the data is available and no sooner, and that's how I share threads. Now, calling get inside the continuation is not a blocking call, because we know the premise of being in that callback is that we have the value available, so we know that for sure. So we can call .get there without blocking. All right. Now, one utility of the sort of the .then construct here, in comparison to some other callback mechanisms or callback UIs, is that you can chain them like this. So you can have at least have the code when it's serial composition. You can have the code look pretty much serial, right? You have one after another after another. Now, of course, we know that each one of these, it shouldn't say async there, it should say createTask, by the way. But anyway, we know that each of these lambdas are executed on different threads that are allocated by the system for us in some way. But at least the code looks serial. And PPL tasks, and also in our proposal for improvements to Stud Future, there's also non-serial composition. You can create many futures, and then you have a when any and when all, which combines. There's a join, either a join or a choice, and allows you to build up tasks from other tasks in that way. So that's parallel composition. OK, so a couple of things that are really basic to REST, or to the SDK, is REST itself. It's really a sort of an architectural pattern, but it is very closely associated with the HTTP protocol. It is, I would say, the predominant modern pattern for web services. The alternative is SOAP, which is far less used. And generally, it kind of assumes in many, or it at least connotes stateless services. The four main verbs or operations in HTTP is get, put, post, and delete, which is essentially the CRUD operations, if you will, of relational databases. But you can extend them. and people do often. Well, not often perhaps, but frequently. So here's an example using Casablanca for a REST call. Getting, and in this case, it's just getting some HTML content from a server. I create a client with the server, or the service, if you will, the sort of the base URI of the, or URL of the where I'm going. And then I can, by using that client, I can now make requests for dependent resources under that. So HTTP requests being network operations, they need to be represented using a task because they need to be asynchronous. And this is sort of the very reason why we are doing sort of taking a dependency on PPL here. And then once you have the response, and you should probably do this inside of then, you just call .get to actually retrieve the response, which is an object. It's a rather large object sometimes. Right? Well, if you don't do it, well, yeah. So this is what you should do. You shouldn't do this, because this makes it synchronous. This makes it asynchronous. Right? All right. So now I talked about streaming and file I/O, and you know, generally a lot of data that we get off of the web is big, and so representing it is not as a sort of a byte vector, but rather as a stream is often appropriate. In fact, in Casablanca, that's the default assumption. It is a stream unless you ask for something that isn't a stream specifically. So in order to get the body of a response as a stream, you just ask for the body. And that's now an asynchronous stream. So we had to invent, as part of Casablanca, we had to introduce asynchronous streams, new construct, different from IO streams, similar in some extent to in the design, but distinct. And all operations on these asynchronous streams are, in fact, asynchronous. In other words, they return tasks, unless they're known to be prompt. A few of them are. Okay. All right, same thing. If you upload a file, that you would want to do that as a stream, so you can stream in upload as well. And what you're doing here is essentially saying, let's see if I can, this is the latest isn't going to show on the web, so I won't do that. But we're passing in, we're opening an iStream, a myfile.txt, so that's the one we're uploading. When we've opened that, and opening a stream can take some time, so it's an async operation, we get a file stream object, and we just pass that into a client request for put meaning like update, right? When that, and then we hook it .then onto the to the request so that we know when the file has been uploaded, we can close it. Okay. So I'm going to quickly just go through a quick demo, querying Bing for a particular result here, right? So I'm going to, this is a console application, so it's going to be pretty, it's not going to be a whiz-bang exactly. But I essentially, can everybody see this? Is the font OK? No? No? OK. All right. Then I will, how about that? Big enough? One more. What about 175%? That. Is that OK? OK, great. So what I'm doing here is, after I check the usage there, I create a stream buffer. That's a asynchronous stream buffer, and I'm going to so I associate that with a output file name. So I do an open, and actually I don't associate it. I open a target file that comes from output file name, and when that's open, then I make an HTTP request on line 55 there, 55 and 56 to Bing, and there's a /search and I put on a query, and the search term I got from the command line, and then I just take the request, and at line 60, it's 60, right? Yeah, at line 60, I get the response, and I just get the body, that's a stream, and I call read to end, and I pass in the target stream buffer, which is the one I opened earlier on, and that's where my data is going to wind up. All right? Then I wait for the read to end, which is an asynchronous operation, as you can imagine. I mean, it's just pulling stuff off the network, writing it to a file. When that is done, I can, and that happens on line 68 and forward, I can close the file buffer. And there was the output file here. And then, because this is a console app, I have to end the whole thing by waiting for the operation to finish. So here I actually have to explicitly introduce synchrony with a .wait, because otherwise my main function would terminate. But in a graphical application, you wouldn't want to do that, of course. You would want to just update the UI when it's done, or something like that. So rather than running this, I'm sure you will trust me that it works. I'm going to, in the interest of time, move on to the next topic here instead. OK. So we also have additional, I mean, there's a lot to HTTP. One of the places where you pass data is in the URI string. One of the places where you can pass data is in the headers. And so we have a way of explicitly adding headers to a request, of course. The third place where you can pass data is in the body of the request. We saw that on the file upload example on a couple of slides ago. And it's all pretty straightforward here. Adding headers is not an async operation, of course. It's just a table of string mappings. Now, the second thing that is pretty fundamental to REST these days, at least, is JSON, JavaScript Object Notation, which is a more compact, standard text-based serialization format than XML. It is more compact. It's also less complex. And I expect that many of you are familiar with it, but it's essentially, if you take JavaScript and you take out a lot of the function logic, etc., you wind up with the ability to write objects as literals, and that's essentially JSON. But in other languages, you can often do the JSON to object serialization and deserialization through attributes or various declarative notions. In C++, we don't have that rich runtime metadata, so we had to go with a more explicit API for dealing with JSON. But it is so fundamental that we built it straight into the HTTP response and request APIs. So there's an extract JSON. Instead of calling body, there are some extract methods. You can call extract string, extract vector if you just want a byte vector. You can call extract JSON, which essentially takes the body of the response and parses it as JSON and gives you back an object model. We tried to stay very close to sort of a table, because JSON objects are essentially maps, if you will. So the API is very map oriented. You create a JSON value in this case, and then you insert things at various for various keys here, and then there's iteration, of course, and all those things, right? So I'm going to go on to another demo where I'm going to not call Facebook. I'm going to not call Bing. I'm going to call Facebook, and I'm going to ask it to list the various albums that I have in my profile. And that comes back as JSON, in fact. And once I have that JSON, I can sort of pull it apart and figure out that there's an image there, perhaps, and there's some names on it, etc. Right? This is what that code. This is when I click. We're going to see the UI in just a moment. When I click to get the albums, I put together this. I already have created the Facebook client, so the actual client object is already there, right? But I just call it .get, and so this is not part of the HTTP thing. It's part of the Facebook client, which is another object here, right? And then when I get the data back, I go through and build up a vector. In this case, we see a WinRT type here. That's the Facebook album hat. And the reason is that we're going to display this in a Windows 8 UI, so we need to mix in some WinRT apps too, types too. And then I'm just going through the data of the response. That's a field in the JSON that comes back, and iterating through. And sometimes the data isn't always completely well formed. So I have to catch the exceptions and ignore anything that isn't correct. And then when I have parsed through all of that stuff, so I have all the albums, then I go here on line 74 and actually just display it in the UI. So let's run that and see how that turns out. So I'm not a UI designer, as you can tell, but beauty is not the purpose of this demo. I'm going to log in. And then the second button is to actually go get these albums, right? So this is that loop that you saw, that code that you saw earlier is what's doing this, right? I'm not actually, the code isn't there to dive into any of these albums right now, but I am retrieving the cover photo at least for all of those, right? So that's that logic right there. I have just a couple of minutes left here, so yay! That's so awesome, right? What's cool about this, in my opinion, is that logic, that loop there, that's cross-platform, except for that image processing, right? It's cross-platform stuff. I can take that, put that in another context, and because C++ is a portable language, or C++ 11, right? Modern C++ is a portable language. It will work on Linux too, right? So what's the current state and what's the roadmap here? We have what I just showed you. We have client-side APIs on XP and forward. It includes Windows Phone 8, Linux. We have the JSON library async streams. The streams are memory-based streams and file streams, TCP streams, HTTP streams. We have an experimental server-side API. By experimental, we mean that we're not we're still reserved the right to make changes to the API based on user feedback. We're a little bit more mature on the client side. And what's coming up is we're going to add support for WebSockets, more platforms. And this is available on the CodePlex site that I showed you initially. It's also shipping in the next version of Visual Studio, which is in preview right now, and shipping soon. And so, what I want to ask you is to try it out, give us feedback, and we are taking contributions also. There's a couple of pages about how to contribute if you want. Casablanca.codeplex.com. And that leaves me just a little bit of time for questions, if there are any.
What compiler do you use on Linux?
So on Linux, it's GCC 4.7 and 4.8 that we have tested with. We have compiled it with Clang on other platforms, but we don't have any. The make files that are part of the distribution on the CodePlex are all GCC based. So we know it builds with Clang, but the latest version of Clang, but we are not shipping the make files for that.
One more
Well, so the question was, how about PPL? Since you're so dependent on PPL, how does that work on Linux? Well, we have it ported to Linux. So we have pulled it out of Visual Studio, and we have PPL on Linux too. And in fact, PPL shipped in Visual Studio 2012, and we have it also ported back to earlier versions of Visual Studio. Yes? Just shout. I'll repeat it.
Sorry. So if somebody tries to send you like a huge payload, if somebody tries to send you like an enormous payload, is there anything in there to stop it from like bringing things down? Well,
so yes. So the way HTTP will send you data typically over a TCP connection, right? And you're pulling data. If you do something like extract string without first checking the content length header, then you're gonna have a big string. But there's data in the HTTP response to guide you towards not calling extract string without thinking about it first.
All right, and you can take more questions at the panel, because you will be on the panel. And now we're going to have STL jump up there. Yep. And thank you, Nicholas. Everybody.